Today, we'll be talking about tests for organic functional groups in AQA A-level chemistry.
A-level chemistry, there are many functional groups within molecules that you need to know. You also need to know the tests to identify these functional groups. In this video, we will be talking you through these and how this will indicate the presence of a particular functional group.
First is the carbon-carbon double bond in alkenes. The test for the presence of this bond is bromine water. Add a few drops of the alkenes, 2 cm³ of bromine water in a test tube. Place a stopper on top and carefully shake. If an alkene is present, the solution will turn from orange to colourless. Next is the OH group in alcohols. Add a few drops of the alcohol to 2 cm³ of both potassium dichromate solution and dilute sulfuric acid. Carefully warm the mixture. If the OH group is present, the solution will turn from orange to green as the dichromate is reduced. However, this test will also produce similar results with aldehydes, so further testing will be required to confirm whether there is an alcohol or aldehyde present in solution. Now, we'll talk about the test for the CHO group in aldehydes. There are 2 possible tests for this. The first is using Tollens reagent. Add a few drops of the aldehyde to around 2 cm³ of Tollens and heat in a water bath. If an aldehyde is present, a silver mirror will form on the inside of the test tube. The other possible test is using Felling's solution. Once again, add a few drops of the aldehyde to around 2 cm³ of Felling's and heat in a water bath. If an aldehyde is present, the dark blue solution will form a reddish-brown precipitate. We'll now go over the test for the COOH group in carboxylic acids. Add a small spatula of solid sodium hydrogen carbonate to a 2 cm³ sample of the acid. If a carboxylic acid group is present, there will be vigorous effervescence as carbon dioxide is given off. Next is the CX bond in haloalkanes, where the X can represent chlorine, bromine, or iodine. Add a few drops of the haloalkanes, 2 cm³ of dilute sodium hydroxide, and warm in a beaker. This breaks the covalent bonds and releases a halide ion. Next, add enough nitric acid so that the solution turns acidic and test using blue litmus paper. Then, add around 1 cm³ of silver nitrate solution. There will be no visible change with the sodium hydroxide or the acid. However, if a CX bond is present, a precipitate will form on addition of the silver nitrate. White precipitate indicates a carbon-chlorine bond. A cream precipitate indicates a carbon-bromine bond, and a yellow precipitate indicates a carbon-iodine bond. Now we have a quick quiz to summarize everything we have talked about in the video. All you need to do is write down the answers. We have given you 2 options for each question. We will give you 30 seconds, but feel free to pause the video if you need more time. Okay, so here are the answers. Question 1. A small sample of sodium hydrogen carbonate was added to a carboxylic acid. There was vigorous effervescence, therefore carbon dioxide was given off. This answer is true. Question 2. A silver mirror formed when Tollens reagent was added to a solution. Which functional group was present? This was an aldehyde. Question 3. A sample of bromine water was added to a solution. It did not decolorize. Was an alkene present? The answer is no. And question 4. When testing for a haloalkane, a yellow precipitate formed on addition of silver nitrate. Which bond is present? This is a carbon-iodine bond. Thank you for watching our video. We hope you have found it useful.